Hello everyone. Okay, we are going to study the last lecture. Okay, so in terms of our remaining schedule, today is the last lecture, which is lecture 22. And on Thursday, we are going to have a review session. Honestly, I don't know what I'm going to ask in the final exam, but what is important is that it's not going to be cumulative and the weight is going to be same as other exams. It doesn't have a heavier weight, okay? Yes, so I'm going to come up with a pretty good formula, okay, which is favorable for your cause, and on the other hand, I cannot really, just lose my standards, right, for the class. So I'm going to announce it, and I'm going to send you that what kind of problems we are going to go over, not just from the lecture notes, but you are going to see a printed material by me, okay? It's in PDF form, so you can always open it anywhere, all right? So today we are going to continue amortization of loans. So this is a summary. Whether you need to buy a house or buy a car, you go to bank, okay? If you have all the cash you need, you don't need to go to the bank. You don't have to worry about it. But most people, yes, we need to go to the bank. And when you go to the bank, of course, the most important thing is, can I afford the payment? Okay? Every month you are going to make a payment. So what is the payment amount? That is the rent for the decreasing annuity, okay? Rent for the principal, that is the borrowed amount. So this is the formula. This is how you compute the rent. In a normal sense, we just read rent, but this is going to be your monthly payment. Okay, so payment is so important. Compute this. The other formula is going to be the other around. You know the monthly payment, okay, in the problem, and you compute that, oh, how much did you borrow, or how much did she borrow, okay, so computing this principal, which is the borrowed amount from your payment, okay, so just going the other around. Therefore, this has to be what? The reciprocals, numerator and the denominator switched, okay, all right, so I want you to make sure that, because the formula gets a little bit complicated, you may say just a positive power over here and the negative power over here. It is not possible. It's going to be just the reciprocal, just you change the numerator and denominator, so you are going to match, and then you see whether you copied it right or not, okay? So let's continue the problem over here, okay? Well, we continue the concept, but this is a very first example in lecture 22. Example 1, car loan. Yeah, today I'm not going to do much over here. Example 1, example 2, and then the practice problems number 2, okay? That don't really conclude the whole semester material over here. Example 1, car loan. In a recent year, Ford was offering a choice of 1.9% loan for 36 months or $1,000 cash back on the purchase of a $28,000 Taurus. Okay, it's a good scenario. So let's go for a car shopping over here, and you want to buy a Ford Taurus. Well, it's not too bad, 28,000. You have two options. Option A is that you are going to have a 1.9% loan for 36 months. Okay. Option B is $1,000 cash back. You get a cash discount, but you are going to borrow money from your local bank at 6% compounded monthly for 3 years. So same 36 months, correct? Okay. And we are going to compare these two options and think about, of course, which one is more favorable for you. Meaning what? which one is going to make your monthly payment lower. Okay, that is the name of the game. And we are going to sort out what is what. Okay, 1.9%, well, that is pretty good, less than 2%. Yes, that is R, correct? So R is 0.019. And the monthly payment, M equals 12. So therefore, what is I? I is going to be really long one. I want to make it as exactly as possible. 0.001583. Yeah, I will go for extra long, okay? And you are going to compute the payment. Well, N is 36. You are going to make 36 payments. That means you pay off your debt. Okay, so again, start with the $28,000 debt. You make a payment. We don't know how much. That's why it's in question mark. How many times will you make a payment? Yes, it's going to be 36 times. So you decrease the balance, and at the end, you are going to make it 0. Okay. So how much is your monthly payment? Yes, we need the first formula, right? So R equals, I is 0.001583 over 1 minus 1 plus this 001583 to the negative N, negative 36. And then times 28,000. Okay, I want you to compute. Again, this is negative power, so find the negative sign, not the subtraction sign on the calculator key. So that gives you $800.77. Yeah, it turns out to be kind of a pretty hefty bill, but this is because in 36 months, that's why. Okay, typically they borrow a loan, well, on 5-year period. Okay, 5-year term, which means a 60-month term. In that case, it's going to be a lot lower. For this problem purpose, yes, your monthly payment is about $800. Okay. Well, it's not asked, but let's think about how much interest you pay. All right. So you make a payment of 877 cents. How many times? 36 times. So let's calculate that. How much is that? 800.77 times 36. Altogether, you pay $28,827.72. You borrowed $28,000, so only this much is the interest you pay. Okay, so 1.9%. That's not a bad deal at all. Okay. Now we are going to switch to the next option. Next option is cash back, $1,000. So the concept, you understand that they will give you cash discount. So instead of $28,000, you are going to pay for the same car for $27,000. But cash back, instead your interest rate is higher over here, 6%, 36 months. So same term, but the interest rates are different. So this time R equals 0.06, M is the same 12, so they make it monthly, N equals 36, same. So what is I? 0.06 divided by 12, that is 0.005, 0.5% per month. That's what that is. Exactly the same, so let's compute. But don't forget, here in this case, principal is 27,000. All right? So 0.005 over 1 minus 1 plus 0.005 to the negative 36 power, then multiply by 27,000. Okay. Of course, I cannot say of course because we are comparing these two options, right? Okay. So one is slightly better because the principal is a little less. On the other hand, the interest rate is higher. So which one is going to be a better option? You don't know until we compute over here. Okay? I have no idea. So let's compute. That is $821.39. Yeah, this is $800, roughly $800. This one is roughly $821. So of course, option A is better. Okay, so that is more favorable to you. Okay, yeah, I'm sure you hear, or you hear, or you on the radio, or you see on TV commercials a lot of things about, hey, we get some even 0%. Okay, so I didn't ask over here, but let's do part D. Okay, part D. They offer 0% interest rate. What does that mean? 0%. So that means you don't pay interest. Okay, no interest. So what do you pay back? Only this principal. So principal of $28,000. So divided by 36. That's all you need to do. Okay? So 28,000 divided by 36. How much is that? That is $777.78. Yeah. Alright? So this is how you understand when you see those advertisements from the car dealers. Okay. Here, the next one is a little more complicated, but you must understand the concept of your payment. Alright, so this is that. The next one is about the concept of loan interest rate. So far, what did you do? All interest rate was always given to us, okay? This time, we are going to figure it out, what the interest rate was. Okay. Well, when you make a payment, I said some portion of payment goes to the principal to reduce your debt. In other words, in simple language, to reduce your debt goes to principal. The other part is go to interest. That is a bank profit. Okay? And when you compute this interest, always the principal is decreasing, right? The very first one is the whole amount you borrowed. As time goes, little by little, you pay back. Okay? You pay back the interest. So the principal. So the principal, the balance is going down. Therefore, interest is going down also. So interest is always interest on what? On unpaid balance. Okay? As time goes, the unpaid balance is decreasing. Therefore, you are going to pay less and less interest, even though your interest rate is always the same. Okay? So here we go. Example 2. A loan with quarterly payment. Yes. Here is a quarterly payment, not monthly payment. Quarterly payment is $1,500. Has an unpaid balance of $10,000. unpaid balance is $10,000 after 30 quarters. After 30 quarters. Next, unpaid balance after 31 quarters, unpaid balance is $8,670 after 31 quarters. So from this scenario, if the interest is compounded quarterly, find the interest rate. Yes. You make a quarterly payment, therefore this interest is compounded quarterly. You have to have the same timeline over here. What is the interest rate? So let's understand this question first. Interest rate. This is always little r, not I. Okay? We may start with an I, but always you are going to give the answer for R, otherwise you are not going to get a credit and by math lab homework, okay? So look at the problem over here. So that's the diagram in the book over here, okay? You are making payments over here, so after the 30th payment, after the 30th payment, unpaid balance UB is $10,000. After 31st payment, okay, unpaid balance is $8,670, and then of course you are going to keep paying back until you pay off the whole debt. Okay, so from here, we don't know how much you borrowed. All you know is the quarterly payment is $1,500. So here we go. When you made the payment over here after 30th quarter, when you make a payment, how much is debt is reduced? $1,330 debt reduced. Correct? So let's look at that. You make a payment of $1,500, but you reduce the debt of just $1,330. So there is a difference, right? There is a difference which is $670. So this $670, where does it go? Yes, that is the interest you paid. So in short, after you look at this, okay, look at this, what you can conclude over here is when unpaid balance is $10,000, you paid interest $670 for interest for 1 quarter, not for whole year, okay, not for 1 month, for 1 quarter. So now you get the concept of, well, so that means your $670 interest was on this balance of $10,000. So what is the rate you paid? Oh, of course, the rate is going to be 670 over 10,000, which is 0.067. Okay, so this is a 6.7%, but the rate for the decimal is 0.067. This is just for 1 quarter. Our interest rate has to be R. That is for the whole year. So what do you have to do? Yes, exactly. So 6.7% for a quarter year. Therefore, what you have to do? Times 4. That is a lot, 26.8%. Yeah, 8, 2 carries, yes. 26.8% for the whole year. So here R is 0.268. Okay? In fact, this one, yeah, interest rate is very, very high over here. Okay, it could be illegal. So I looked up the legal limit for the interest rate. But this is a huge difference over here. Legal limit is, I think, different from state to another. Okay, so 25 to 45%. If you go higher than that, that is going to be a misdemeanor, up to 6 days in prison. Yeah, that's what I saw. But anyhow, that is beside the point. Over here, just mathematically, that is 26.8%. That's what you compute. All right. Okay, so get the concept. You have the quarterly payment, and you are going to look at how much debt was reduced. That means that amount went to the principal, and the rest of the payment goes to interest, which is $670. Yeah, $1,500 minus this. Okay, so. So 1,500 minus 1,330. And that interest was based on unpaid balance of $10,000. That's how you find the rate, which is 6.7%, but that is for only 1 quarter. So for the whole year, times 4. Okay? All right, let's go for the last one. That is page 102, practice problems number 2. The other concept over here is, well, I don't want to introduce anything new over here. This one was good enough, okay? Good enough for the finance problems. So, page 102, example 2. A car is purchased for $22,000 with $2,000 down at 4.8% compounded monthly for 4 years. Okay. So let's change this one too. A car is purchased for $20,000. Let's change it to not the 21, not 22,000. Okay, not 22,000. Here is 20,000.